at USD, and we coordinate several research projects, and we have given a range of publications, and this is from this one. Please.
Thank you. Well, it is a pleasure for me to be the very first presentation here in MEDES. Well, I will present this work. It's a result of a conjoint project between Universidad Bolívar from Venezuela and Université Paris-Dauphine, Paris-Nanterre. A knowledge-based approach for self-healing service-oriented application regards to how to manage the knowledge of the information during the execution of services to resolve problems that can arise during the execution of those kind of applications. I will start with some preliminary basic concepts related to my work, to this work. Well, this work is in the context of composite services. A composite service is a set of services that work together to respond or to satisfy a query, a user query. A user query is represented by some inputs, some outputs that the user wants to obtain, and some user quality of services preference. For example, the time, a restriction of the time that the user wants to have the response not more than 5 minutes, for example, or some other quality of services preference. Well, then this set of services has to work together in a coordinated way to produce these outputs from the input and considering this quality of services preference. This control flow, the execution flow, is represented by an acyclic bipartite graph. Because there are many, in a composite services, there are many services that are working together, they have to comply, they have to accomplish some properties in order to ensure the system consistency. It's more related to the all or nothing property that we can see in databases. And then there is a property called atomicity in databases systems and transactional system. Then it is more or less in this case the same. In this case, composite services is atomic if all their services finish successfully. Then all changes have to be kept in the database without the possibility to undo these changes. Or if during the execution one service fails, then all the successful services previously executed have to be undone. There is another property called compensable. Composite services is compensable if services are compensable, and a service is compensable when it has another services that can undo. For example, for a hotel reservation, its compensation services cancel the reservation. Another property is retrievable. A composite service is retrievable if all its components are retrievable. And one service is retrievable, it can be invoked many times, and in a limit number of times that it is invoked, it will successfully be executed. Then, regarding to these transactional properties, there are some recovery techniques, because these transactional properties are to ensure the system consistency when failures can happen. Then, based on this property, there are some recovery mechanisms like backward, forward, and semantic recovery that I will explain in the next slides. But there are also another techniques like checkpointing that can be implemented independent of the transactional property. Let's see a little bit how it's the. In this case, let's say that this is the time, and then there are some services that compose of composite services that are successfully executed, but sometime, in any moment, there is one service that can fail. Then, in that moment, the system has to apply a recovery technique. Depending on the transactional property, that technique could be backward recovery, in which all the successfully previously services have to be compensated. Or if this service is retriable, then it can be invoked until it's successfully finished, or maybe it can be replaced by another equivalent services to, in this case, we call forward recovery, because the idea is to try to finish, to execute all the services and have the response. There is another technique that is called semantic recovery, because even if all the services have finished successfully, later it can be compensated. But if we don't have all this transactional property, then when the failure happens, then we can take a snapshot and then resubmit later the same composite services, but from the point when it was failed. Then we keep this work and we start from the failure in advance. Well, then the question here is, which mechanism is the best according to the condition of all the execution? That's the idea. That's the idea that we have to respond. If we have a static selection of the mechanism, we can have some problems. For example, quality of service degradation. If we retry services, this many invocation will degrade, could be degrade the quality of services that the user asks, or maybe if replace the service by another that is that costs a little bit more. Could be also we can also have quality of service degradation if we make checkpointing too early. It could be a loss of time also, because the checkpointing is too early. It's like we can start from the beginning. Or if we make compensation, well, we have lost work. Because the compensation means we have to undo all the services that were done before. Then, what kind of information we can use to improve this decision about the forward mechanism? Then we have knowledge about each service, that is composing the composite services, and we have information about all the composite services, all the conditions. Then we will see how this knowledge can be obtained. Then in this context, that we have transactional property and that we need to keep the quality of services, quality of services criteria, how can we provide quality of service award full tolerance approach for composite services? Then our contribution is we propose a self-heading composite services approach that ensures the quality of services criteria based on transactional property, checkpointing, agent's knowledge, and of course keeping the quality of services preference. In our system, each service that it's in the composite service has a service agent. We call service agents. Each service has a service agent, and then the composite services has many agent services taking care of the execution of each service. And there is also a coordinator agent that is in charge of analyzing the complete composite service execution. Each service agent that is it's in charge of one service in the composite services has knowledge about him and about the complete composite services, and makes decision based on what is expected to happen, what really happened, and what it remains to happen. That's the self-healing knowledge. Well, just to give some examples, as I said, there are some information that is related to each services and some information that is related to the complete service, composite services. Each time, each service has an state. It could be running, it could be executed, it could be compensated. But each time, every service has a state, and there is another information related to the. Here we are considering only time, price, and availability as quality of services criteria. And then there are some values related to this quality of services criteria, the expected time, the real time, and also there are more some kind of time information. Then there is also an information related to the quality of services state and the self-healing state. Those are the most important, because those are based on all this information. And I will explain a little bit how to obtain this kind of information. Okay, quality of services preference. We have two notions regarding to quality of services. The expected quality of services, that is based on the expected value for each service, and then for the complete composite services, it's just the sum of all of the time of each service that is in the longest way, because all these services can be executed in parallel or sequentially, and then the total time for the composite services should be the services that are in the longest path. Okay? And the same for the price, is the sum of all the services, and for availability is the multiplication. Then we have the expected, and we have also the acceptable. This is the degree of the acceptable degradation that the user can accept. And then it is given like parameters. Then I can weigh. If I said at the beginning, I can wait 5 minutes, well, I can wait also 7 minutes to have my response. It's just a degree of the degradation of such a criteria. Well, based on that, each criteria has an state that can be normal, degraded, or broken. Normal, it is in the range of the user expected. Degraded, it is not more than the acceptable, but it's still acceptable. And broken, it is this criterion. It's overcome the limitations. Okay. Well, regarding to the other state, the self-healing state, each service agent can have a normal, degraded, or broken state, depending on its condition about the quality of service criteria and other information. And also the complete composite services will have an state depending on all its service agents. For example, for normal, if all its services are normal, the composite is normal. It's in the degraded state, then the composite service is degraded, and if one service is broken, then the composite service is all broken. Well, I will skip that one. How is my time? Fine. Well, based on this information, each service agent has to perform detection based on the quality of service degradation, perform a diagnosis based on the state of the composite services, based on the availability recovery mechanism, what kind of mechanism can be applied, and based also in the user preference, and perform the recovery technique according to all this decision. This is more or less the architecture of each service agent that, based on all the knowledge that I showed before. Then it detects, depending of this, detects failure, detect the behavior degradation. Then based on this detection, it diagnoses, depending of which state it has and which strategies are available, and then that's the actual technique to recover the execution. The service agent knowledge then it's a triplet defined as the set of possible conclusions. The conclusion could be continue, retry, make checkpointing, replace, substitute, compensate, etc. The set of several finding that all this the knowledge or the knowledge that each service agent has, and the rules that based on the preference, the quality of services preference, and based on the knowledge, the rules will say which is the best technique to apply. This is just an example how rules are defined. For example, if in this case it says if the composite services or it's in the broken state, then the rule would be if this is broken and it is not compensable, but I have some time to still to be between the preference of the user, then I can retry this, re-invoke this service if it was this failed. Or also I can replicate the service just like a way to prevent that it can be failed. Because if I replicate the services, then it is failed, and then that one can continue. Well, in that key is just an example of how rules are defined depending on the information and depending on the state. Well, we did some experimental evaluation with these composite services. That is an e-health application. This is a bipartite graph in which these rectangles are the services, and this is the input and outputs that are received by each service, and this is the flow, the execution flow. Well, we submit these composite services in 3 scenarios. And a scenario without no fault tolerance. It means that if one service fails, nothing to do. It's just the user will receive just an error, a message saying that a service fails and there is no output to give to him. A pure transactional composite service execution just based on transactional properties. It means only backward, forward recovery. And our approach that is based on transactional property, checkpointing, and all the knowledge that I already explained. Well, this is those are the values for each criteria, quality of services criteria that each service has. Each service has this. The mean of the time, the execution time for this service is that one, and that's it. And this is the aggregated value for the whole composite service. Well, we only take into account 5% of the only 5% of the time the user is able to support 5% to more time. And then those are the results. The result, that one means that in many in 30% of times, the composite services do not respect the quality of service criteria. It means it goes timeout. It finished, but without respecting the time constraint in that case. In our approach, all composite service execution that finishes, all of them consider this time. What else? When the compensation time in the transactional property, most of the time, the transactional property, the transactional property scenario decide to compensate, and then that's because there is more time on compensation. But in our case, not all the time was the compensation the decision. It was more to go to at the end more forward recovery. And regarding to resource wastage, in our case, the most important is how many outputs there were when the failure happens. If I have some outputs for the users, and then the best decision is try to finish. And then in the case of the transactional property, it was 2% of outputs lost because the compensation was applied. And in our case, when there are some outputs already, and then the system tried to finish to get the other outputs. Okay. Then this evaluation showed that we need to provide fault tolerance mechanisms for composite services in order to keep the system consistency. Our approach handles composite services failures using transactional properties very well, but makes better decisions. And our self-healing approach builds on top of both characteristics, transactional property and even knowledge. And we are finished. We have this approach based on transactional, checkpointing, knowledge base, and we are tending to make more fault identification, more failures, because now we only consider crash, but there are another type of failures. Then we will consider another type of failures, and also another failure mechanism. Try to do self-configuration capabilities and learning, and self-healing internet web of things application. Thank you.
Are there any questions?
Yeah. Thank you for your talk. In the beginning, you make assumption that composition is a directed acyclic graph.
Mm-hmm.
So what happened with this cyclic graph? In some composition, you can go back and repeat n times some execution.
It will, no, in this case, it will not. It will be represented as a cyclic, because otherwise it was because we used Petri-net formulas to represent the composition, and then in that case, if we have cyclic, then we have to represent like direct, exactly.
Okay. My second question is, for your single services, they should be side effect. I mean, a service or modified data can crash at the middle of processing. So what happened in this case? Are these side effects or without any side effect?
No. Well, we suppose that each service complies the transactional property itself. It means If it crashed, then the rollback maybe had to be applied, but inside this the service, not as the composite service. But each service has to comply also the transactional property. Otherwise, it will not.
Thank you very much.
Is there another question? Yeah.
If I can, because I'm not expert in this area, just probably stupid questions. The first one is related to the inference engine. You said that you are using an inference engine in your framework, right?
Yes.
And I was wondering why you are using it, because I didn't see if you are using it for rules or you are using it
For rules, just for rules.
Oh,
Just
for rules.
Just for rules. Yes.
Is it like expert rules? Or do you learn these rules? Are you
Our rules are more simple. Just to maybe my students I have to say call this too much call it like inference, because it's just to process the rules. It's just to process the rule based on the predefined conditions, and then to have the decision at the end.
You may have like some feedback and learn which rules are.
Could be,
best.
yes.
And
Now we
these
don't
are further
exactly.
rules.
Well, we don't do that, but it could be actually it's here.
Yeah, very good.
Yeah.
Exactly.
Small one?
Yes,
That one?
very short. Yeah, the second one is related to your slide number 22, I think.
22?
Because once again, I'm not expert in this area, but I wonder how I should. Yes, you are mentioning about the diagnoser here. I have 2 documents, and my output is 5 documents. So to my understanding, I should have only 1 output. Why I have 4 outputs?
No, you can have many outputs. For example, if in this case, I have 5 outputs, but for example, if I...
Here you have inputs, but for the diagnoser you have 4 outputs.
For the... Where? Here.
Yeah.
For outputs, I mean, based on the diagnosis, you can call the emergency or notify contact or notify doctor and display message. Maybe it's just one document, just one diagnosis, but it means that you have to.
So it's only 1 output, and I have sort of or exclusive
Is it
or
4
something.
together or
No, those are.
is it like a one?
No, I think there are 4 outputs, and 1 output is from different output for different services.
According to the diagnosis.
Yes, according to the diagnosis. Maybe.
But usually we don't have only 1 output. That's my.
In a query?
I mean, usually when we are designing a web service or a service, I have maybe set inputs, but I have only 1 output.
Well, no, you can have more outputs. It depends because of the parameters, and the web services itself can have parameters. There are outputs parameters and also
but it's
a
only 1
response.
output.
Yeah. I think I understand this way, that it's like 1 output composed.
Composed by maybe by
So I
several,
have-
yeah.
The same as French
Yeah,
alphabet.
Thank you. I'm sorry for my mistake.
No, it's okay.
Thank you very much.
Okay.
Presenting
thank
this
you.
paper. Thank you. The next speaker is Patrizia. This is the way you pronounce it. So we received our degrees from the University of Rome, and she's now a researcher at the CNR of Italy. And she was also from 94 to 99 a contract professor at the University of Lacerda. She's an author of more than 200 papers for numerous books and conferences, and she was scientifically responsible for CNR for some European and national projects. Her main research interests are in digital ecosystems, statistical databases, geographic information systems, web applications, human-computer interaction, visual interfaces, and some social informatics and social networks, and responsible research and innovation. Thank you.
Thank you for this opportunity to present this paper today, and I am presenting this paper that is on social and language self-adaptation in digital ecosystem that I do with Arianna and Fernando Ferri. We started in this work by the concept of socialization, and socialization as a crucial issue in natural ecosystem. We started considering this concept at the base of people that learn social norms, skills, and knowledge and values in a group. And this concept is very relevant also for the communication process, and in particular it characterizes digital ecosystems, considering the process that involves both humans and devices in general. And so our goal is to develop a common understanding and a self-adaptive language that allows involve biotic and abiotic elements and actors in the digital ecosystem, so that with this paper we aim to provide some theoretical foundation concerning these concepts. And starting from an example, we can have also this morning in the talk that introduced this conference, we saw different elements that participate, that provide information, that provide documents, structure and unstructured information. And we have different actors that provide this kind of information. We can have people, sensors, web application, any kind of source, and but each one speaks some language that is different, even between humans. Even if we speak the same language, meaning native language, we can have that if I am a computer scientist and I go to speak with an economist, we have some difficulties because with the same word we mean something of different, or we don't know what they mean, or they don't know what we mean. So the question is to build this common understanding. And this concept that is very relevant issues for human communication and interaction is in our understanding is also a very relevant question that we have to consider when we go to communicate in a perspective where Internet of Things, Web of Things, all is going to be very, very pervasive for our society. So if I am a person that I am at the bus stop, I want to know when the next bus that is 40 bus arrive. I can ask where is the bus now. The GPS came return me this information, but it returns, for example, in a geographic coordinate. But if I am a common people, probably I don't understand what this coordinate means. So we have to establish this common language, and the lack of effective communication interaction is the problem before. So we start as we have the goal to build an adaptable and extensible grammar formalism that is able to build the core of this common language among digital entities and humans acting in the digital ecosystem. And already, obviously, in digital ecosystem there are some practical solutions, but mainly they consist of solutions that act between the digital entities, not humans also, and they mainly go to address these problems considering communication standards between networks and so on. So we have quite a different purpose, that is the lack of a unified socialization and communication framework. This is our goal, that try to interconnect all kind of actors that are in the digital ecosystem. So the problem is can be defined as we can consider that given a digital ecosystem where we have humans as well as abiotic, abiotic actors, non-living actors, each organism of a digital species is referred as a digital entity, and all the digital entities have to socialize and communicate and share their knowledge for various purposes according to the different contexts, application field, environment, etc. And each digital entity should be able to represent and express a message with which it interacts and communicates with the other parts of the digital ecosystem, and the socialization process is necessary to learn and the message and they react consequently, providing an answer response. What we propose for this? We propose a linguistic approach where we propose a language self-adaptation method that consists mainly of two steps. The first step consists of considering a multi-stream message acquisition from people, from the different devices, from the web and so on. And the second step consists in the language generation that can be divided into two phases. The first, the language generation consists of the grammar definition, where the grammar is defined allowing to the different agents to be represented in the grammar. And the grammar learning allows when a grammar does not represent a message, for example, this grammar can learn, a learning process, can implement a learning process, adapting herself. And at the end, this grammar is available in the to the human and digital entities for having this common language. if we go to the multi-stream, that was the first step, we can see, for example, that we can have a different stream in input. For example, you can see if I have a sentence that is how soon I get home expressed by speech, I have to consider this sentence, this stream that is in input, considering different characteristics of this stream that is in input. What are the characteristics that can be interesting by the point of view of the language? In our opinion, the value of the element obviously is relevant. That is how each element of the stream has the value that it has. The second element, by the linguistic point of view, is for sure the syntactic role, and this is in languages also, but also the modality. In this case I have only the speech modality, but I could have also different modalities with the same messages that are combined. For example, mainly if we consider sometimes elements that come from different sensors, and we have to combine these different elements. So that the definition of the digital ecosystem grammar starts from the providing the syntactical framework from ecosystem and enhancing this paradigm by empowering the agents with the semantic language abilities, those use of multimodal attribute grammars, instead of context-free grammars only, for adding some elements of the semantic. We have here the definition that we propose. In particular, we have that a digital ecosystem grammar is defined as an n+1 tuple, where the grammar is composed by the environment as the first element, that is described by the context-free grammar, and the agents, where its agent is described with a multimodal attribute grammar, because we need mainly to have some elements that are the attributes that have more semantics, because we have that each agent needs to express obviously the what we need to, for each agent we have to express the messages that they send to the other, to the environment, they exchange with the other agents, and we need to represent in using what means they are going to send or exchanging these messages, because also the modality has an semantic level that we can have in this representation. So, I don't know if it's so clear, but in any case, I can have some attribute where, for example, the terminal symbol are the values of the attributes, the modalities, and the syntactic role. And we have that these three elements are the values for each, for expressing each non-terminal symbol that go to form the sentence that is the main, the starting symbol for the grammar. This is an example of multimodal attribute grammar that we provided. And coming back again, if you mind, we had here that one was the grammar definition, the step. And now we have the interaction, learning, and evolution action. To reach shared language, it is therefore necessary that the grammar of the different agents evolve by learning new rules, making it possible to interpret the different messages. So, the first phase is the interaction, and an interaction action of the agent AI with the environment consists of a message that is going input, and where we consider that a new rule is produced and a new terminal value is given. A learning action of the agent AJ that follows an interaction of the agent AI consists of the application of the grammar learning algorithm to the input message, so that each agent different from AI can embed this knowledge. An evolution action of the environment E following an interaction of the agent E consists of the following operations that are over the terminal symbol and the production rules of the context-free grammar, the adding of the new terminal symbol, and the adding of the production rule that was from the message that was exchanged. So we have that this can be schematized in two steps. The first step is of the grammar learning algorithm consists in the fact that we receive in input the message, analyze if this message can be generated by this existing grammar. If it cannot be generated, we have to select the production rules, candidate production rules, and we have to select the production rule that can generate the message that we received. Once we have generated the new grammar, in the second step we have to evaluate the description length of the grammar and to optimize it for avoiding the over-producing of the grammar. An example, coming back to an example of transportation service, let us suppose that the digital ecosystem consists of 8 non-living entities, 3 video cameras installed along the route of traveling, and 5 GPS on the buses and some entities. We have that we can have these sentences, these messages that are exchanged between the different agents, and At the starting time, the digital ecosystem grammar is composed of the 13 agents equipped with the multimodal affective grammar, and the environment is represented by the empty context-free grammar, composed only by the starting sentence. And if the passenger send a message, this interaction produces the learning action, and therefore at the end of the action each agent has an updated grammar G first AI that includes also the production rules and generate and interpret the input message and J. So the environment at the end, detecting that the agent A1 is now connected in the digital ecosystem, will perform an evolution action that consists in adding the agent A1 in the terminal symbols of the context-free grammar and including the production rules where in the initial state. Finally, concluding, the main innovative aspect is to provide this framework that allows to implement a dynamic process for socialization and communication. It is the point of view mainly of humans. We need to acquire the point of view of humans also when we exchange information and messages with devices, with application, web application, and so on. This interaction is inspired by what happens in human communication, and we are going to test this approach in future works in a specific context. Thank you so much.
Questions? Yes.
Thank you for your talk. Before the transportation or the message exchanges happen, I was wondering how the agents or the digital entities, whether they are human or other elements, are really represented in your digital ecosystem. How the agents, whether they are digital or human, are represented in your digital ecosystem before the transportation or the message exchanges happen. Can you say something about this?
We represent each one, the knowledge of each agent by using a grammar for each agent. Each agent has his or her own grammar, which interact with the other agents. We have two levels of grammars. The first one is context-free grammar that allows to have the representation of global environment, and the other level is the representation of knowledge by each agent that has the knowledge of each, the semantic of the messages that are exchanged between the different agents. This is our approach and proposed model.
How will you assess the quality, or are there any indicators, quality measures to know if the implementation
Yes.
of the tests?
We don't have now because we don't have any implementation.
How will you know that it works or How will you measure the...
What kind of measure?
Yeah.
Yes. We wanted to measure considering a test that consider we consider the digital ecosystem and compared with the human judgment with respect to the level of common understanding when they go to communicate. This is our main goal, and this is the first kind of measure that we go to do. Yes.
Yeah, sure. Sorry.
Thank Patrizia for your
Thank you.
presentation. I have two more questions. The first one is, do you consider here that the agent itself could be complex agent which is a digital ecosystem, or you assume that I have a digital ecosystem and I have all the agents, so they should be atomic?
We assume this because the second assumption, meaning that we assume them, the agent, as agent of communication. So, in the other elements are not considered in our universe. Obviously, an agent can have different, very complex structure, but from the point, if we consider them only by the point of view of communication, it is not it is the unit that communicates with the other one in any case.
And what do you mean by, I saw that the quality, I saw it quickly, you mentioned multimodal attributes?
Yeah.
What is a multimodal?
We mean that in the level of knowledge of each agent by the communication point of view, we need to establish not only the terms and the syntactic role of each element, but it is also important to consider what are the different modalities that are used in the communication process, because we saw also in past studies that the modality can contain some relevant information also by the point of view of semantics. The use of one modality instead of another one can contain something that is not semantics but is strongly connected with, and can be relevant to combine the different modalities that are used, mainly because we are considering this kind of communication that involve different devices, different elements, and this is the reason why we used this information, so that for each message we consider some values that are the value that each terms has. The other attribute is how these values are exchanged with the other agents and so on. And this is particularly relevant because when we go, the impossibility to communicate can be also connected with the wrong modality used sometimes. So we need in a common language to also have this element for be sure that each one can receive and can interpret and can understand what the other one are saying.
Is it very short?
Yeah. Have you considered any moderator or coordinator to have you considered any moderator or coordinator to facilitate the communication among the agents, or just one agent is simply communicating twice?
We now consider it this model, but it would be very interesting. It is for modeling the communication, very interesting element to enrich. Thank you so much.
Okay, thank you very much.
Thank you.
And our last speaker. And it's again Flavia? Yes. Our last speaker is Andrea Resmini, who is a professor, researcher, architect, and information architect. Also of pervasive information architecture and reframing information architecture. He's also editor-in-chief for a journal of information architecture. And Andrea is also a compulsive reader, compulsive writer, and piano player. Maybe we will volunteer.
There's a piano. So thank you so much for having me. Thanks for being here. I understand I'm the only thing standing between us and lunch, so I will try to make it as painless as possible. But there will be a little pain, meaning that so far this will be probably the only talk during the morning that sort of gets on the left side of everything we've been saying. So the approach I'm going to be describing to you, which is part of the work that I conducted with Flavia Lacerda from the University of Brasilia, is mostly a design-centered approach to ecosystems. So much of this will be sort of like very imprecise and very sort of emergent in respect to some of the things that you've heard so far. Our point of view starts with the idea of convergence, which is of course a phenomenon that has been sort of like differently described by all of the speakers so far. But for us, it was the idea that we've been witnessing a world that has been slowly turning into an interconnected layer of many different medias that people call more or less at will. And convergence has brought along a number of changes, and I'm using a picture of Uber over here just because it's sort of like one thing that is in the media and probably everybody knows about, as one of the services of late that sort of like completely cross over between digital and physical, because of course you use a mobile phone or an app or a tablet in order to actually get to services that are in the physical world, like as concrete as a cab waiting for you to take you to some other place, and also that mix together the various forms of social media that we've been using and seeing so far, meaning that we score the drivers score us, and that changes the whole ecosystem around us. The interesting thing with what has been happening with convergence so far, at least from the point of view of design, of course, has been that we have quite a lot of different ways of describing cross-media, especially coming from media studies, and you have a list of those on your left side. Things like cross-media and transmedia and now transmedia storytelling have been around for quite a lot of time now, especially following the work done by Jenkins originally around the beginning of the 2000s. And they are descriptive methods or descriptive frameworks. Cross-media mostly looks at this interconnectivity of the different things as a production mechanism. Somebody now decides that we need to consume more entertainment or different entertainment, and allows us to pull the different sources across a number of very different media. Comics, movies, TV, you name it, merchandise, of course. Through the years, the emphasis on production has moved towards an emphasis on consumption, even in the world of media studies. And that is especially evident with transmedia storytelling, which is basically sort of like an updated version of what was there before, but with a greater emphasis on the fact that people are participating. And you can sort of like guess it by the name storytelling, that the narrative element that spans the different mediums is actually very, very important to the overall experience of it. These frameworks are by far very, very mature in terms of the way they describe the phenomena that we are talking about. While the ones that you have on your right are mostly used by the practice of dealing with products and services in a convergent environment are definitely not so mature, but on the other hand, they are generative. And that's a huge difference that we see over there. So you probably know about multi-channel. Multi-channel has been originally created in marketing as a way, again, to describe the way that you could, for example, deal with a bank either by visiting the local branch or by calling them on the phone at the call center or by going through online banking. Multi-channel
The Lenovo Yoga
has then
Tab 3
been
is
adopted,
an
of course,
affordable
by all the
Android
people that
tablet with a
actually
few
create those
impressively
services
practical
and those
features, and
products,
I really like
and
it.
it's still
My
pretty
favorite
much
thing about
a
it is this
siloed
right here.
approach.
The chunky
It's
rounded spine makes
predicated
it
on
comfortable
the
for
fact that
one-handed
all
use, and it
these
houses a
different
useful built-in
things,
kickstand
the
in the back.
websites or
That's not even the
app
coolest
or
part.
the local
There's
branch
also a rotating
live by
camera.
themselves
It
in the
rotates
space that you
180
can't
degrees, so it doubles
connect.
as a rear and
So they're
front-facing
sort of like
camera,
work on
and it actually
exclusivity
takes
of
pretty
their
good
own
pictures.
offerings. You
Additionally,
couldn't be
there's
able
also
to
a great
start
set of
a
speakers on the front
transaction
that sound crisp and clear when watching movies.
the online app and
These
then
might seem like
conclude
boring
it talking to
features,
a
but they're
person
rare
at the branch
finds on a tablet.
in
For only
a mature
$170,
multi-channel environment. Around the mid-2000, some people, including George Grossman, who is the one who came up with the idea of bridge experiences, started to see a change. People were starting to connect things in order to get to future desired states. And bridge experiences basically tells us that with the availability of mobile connectivity and with the larger, push of smartphones and the general idea of, personal mobile computing and ambient computing that comes around those years, the iPhone, the first one is from 2007. People have even more control than what cross-media and transmedia have been telling us. And they can actually, or should be supported in their switching between the different pieces of their own journeys. This is where cross-channel and, to an extent, omni-channel, which from my perspective is simply a different denomination for the same phenomenon, and I will keep using cross-channel through the rest of my talk. This is where cross-channel comes in. Cross-channel, again, is from marketing, but has been adopted in what we call user experience, of the design of digital elements and information architecture around 2008, 2009. And the huge difference is that it's basically originally a version of cross-media that doesn't stick just to media consumption or production, but it is concerned with the way we actually use services and products. And it was basically a heuristic approach to designing things for a convergent world. The interesting thing is that moving forward, trying to make these things more mature and more useful to both the user side and the production side, we find that there's a number of problems that come in. Organization-wise, so from on the side of the people providing us with services, and this might be the municipality or a company or anything in between, convergence and the rise of complexity that comes with it because of users and because of the possibility that they have to connect things that are not meant to be connected in some ways, produce loss of control that cross-media and transmedia have only glimpsed at. And the best example that I can give you is a very, very simple exercise that we did a couple of years ago with people at my department, thinking about the experience of going to the movies, which is a typical complex experience that we do today, but not really complex in terms of what it involves. I do have a rundown, synthetic, very simplified version of simply 3 paths that allowed people to get to see the movies over here. We collected more than 50 just as for the example. Of course, you can imagine that you could go larger. So the colors over here represent different paths to get to the movie, which is over there, the final goal. And some of these touch on the same touch points, which are those circles that you see, the different moments where you move along in your journey towards your final experience. And another one over here is completely out, involving having pizza with friends at somebody's home and then actually just going to the movies, while the others are much more linear in some ways. You can see that there are elements that were mentioned but not used, like Netflix, which was a negative sort of point into the experience. Should we watch Netflix or really go to the movies? No, let's go to the movies. So Netflix was there but not used. As many others, restaurants or elements that were left unnamed. This is a simplified version. Of course, this could be larger and could be also much more complex in terms of the connections it involves. It is interesting for us because this is the first very, very simple visualization of the space of the ecosystem in terms of how the many different actors, as we call them, go through their own experience. For us, that also meant that we were sort of like seeing that while the interactions along the different touch points change or vary greatly, because it's very different to talk to someone using your mobile phone and trying to send a message as opposed to speaking verbally to somebody who's in front of you, or trying to do any task using a kiosk or a credit card. Those things involve very different ways of actually performing. But in general, the structural clarity of the information that is being transmitted along those paths and into the ecosystem is, for us, the primary element that we can use. Of course, it's not the only one, but this is our own contribution. The primary element that allows us to allow the different actors to go along and get to the end of the journey. Because regardless of whatever they do, these people are only interested in the movie itself. So all of the rest is a part of the experience, but not the primary element. So from this perspective, design-wise, we say that cross-channel experience design, which is what we call that thing, is a cross-channel ecosystem for a number of reasons that I will say, but allows us to introduce a strategic as opposed to tactical, like, let's try and build the best app ever. That's not the goal. And systemic, meaning that of course we're looking at this thing from all sorts of systemic points of view. That allows us to focus on the overall architecture of the ecosystem rather than on the individual points. The reason for doing this is because that thing is an ecosystem, even though it's created by user intervention or actors' interventions. It's a transient structure that exists. Because of the way these elements are connected to each other, we know that they are the source of both the system or ecosystem behavior, function, and purpose. And so for us, the way we can structure, we can observe the information architecture of the ecosystem becomes the primary element in the generative design process. And this is a thing that we couldn't obtain from cross-media because that's not generative. So this is a definition that we use, even though it's complex, but I will explain it. So we say that a cross-channel ecosystem is the ecosystem resulting from actor-driven choices. And that's one major point. So we totally embrace that there's an idea of loss of control in the way people go through their experiences. Any actor goes through an individual path, and many actors together will allow us to have an overview of the ecosystem. The way this is built is by using, coupling in any way, touch points that might belong to an infinite number of systems. They actually don't, but of course, theoretically they could, that might be even competing against each other, right? Netflix competes with the movies, competes with IMDb, competes even with the restaurant in a certain way. For the only purpose of getting to a strategic final goal or a desired future state, which means I want to see the movies. That's the only thing I want to do. In order to do that, my experience, even though not encircling all of the ecosystem, is a piece of this larger transient ecosystem. We also say that the cross-channel ecosystem is a semantic construct from this perspective. It connects things that are not physically connected only on the base of sense-making, right? And it straddles physical and digital space, because of course people do not really care if a thing is a digital piece of signage or a physical piece of signage or a person giving them instructions maybe to where the bus stop is. And it's structured around the idea of experiences. People trying to achieve goals. As such, cross-channel ecosystem may include any number of people, location, devices, software, all interconnected by information flows. And that's why we have an information architecture-based approach. There's a huge change in the terms design approaches these things, because design tends to be, at least for now and in many, for many in the practice especially, to be sort of a problem-solving activity where you're given a problem and you provide a solution. In general, cross-channel ecosystem identifies space of challenge and opportunity and not a finite artifact that you can actually deliver at the end. You shouldn't fully manage or fully design it. You're just looking for ways in which your organization or your company in some ways can take advantage of a certain situation to improve or to actually make their position better or existing at all. There's an interesting tension there from the user side, which of course is not concerned with the way it works for them, but it's mostly a thing that designers need to approach, is that experience is a linear thing for all of us in terms of the way we describe it. I woke up this morning, I had breakfast, and I came to the conference. But they happen within a non-linear ecosystem composed of many different parts, which I don't see simply because I discard options as I move along. To be able to describe this in a very formal or more formal way, very formal in terms of design, but of course very informal in terms of the things you're used to normally, we have a number of elements that we use. So we start from actors, which are basically our users, but we use the term actors because of the idea of agency they have within the system. So they are all of the agents that do something within the ecosystem. And of course, agents can be non-biological. It could be software, it could be triggers, it could be anything. And actors pursue a desired future state within the ecosystem. They are able to change their state. We have the tasks or the activities that any of these actors perform in order to move along the different paths that they walk. We have the touch points, which are the individual points of interaction that you have along a path. And you can see one over here with the Disney Magic Band. And touch points are medium specific. So a touch point can be biological, like a staff member. It could be physical, like signage, and it could be, of course, digital. But they can only be one thing at a time normally. It's very difficult to be both software and person and be the same touch point. And they consent people to move along their journey. These are the moments where people either introduce or pull information from the system. This is where, for example, you go to Facebook and you post pictures of lolcats, which is probably bad information or bad content, but still makes up for a lot of that. And then we have seams, which are the thresholds between touch points. So whenever you can move from a touch point to another touch point, you have a seam between them, which is like a door. The interesting thing is that because of the way information is actually medium specific, so it can be, as we heard today, part of a database, but also something else, and it can be actually embedded into different physical states. The idea that the touch points have seams between them allows us to bring in a design artifact into the picture, which is the idea of channels. Channels for us are ecosystem level layers or pipes. Just imagine them as pipes over here carrying water around the city. Any single time you have a tap in there, that's a touch point. Whenever you have two different pipes connecting, you probably have two different channels being connected through a system of touch points. So a person sending you to a mobile app that would move you from one channel to another, possibly from physical to digital, whatever is the name. And it's interesting for us because, of course, channels do not really exist from this perspective, and this is a difficult concept for many designers. So they are like a sort of like very, very fuzzy Aristotelian categories or containers, pipes of information that allow us to take things around the ecosystem. They are also an indication of how good the ecosystem is, because as much as we can sort of like move through them easily or introduce information and have it available, we increase the resilience of the ecosystem. As a final thing, I just wanted to go very, very quickly through one example of a project we worked on at Johannesburg Art Gallery in Johannesburg. The gallery is in downtown Johannesburg. It's the National Art Gallery containing both European and African art. But it's in one of the most run-down areas of the city, and there's a lot of buildings being squatted, an area that you shouldn't be, familiar with if you're just a tourist, because it's dangerous. It could be dangerous at certain points. So one of the big issues on the table when we were involved with the project was, should we actually keep the gallery here open, or should we just close it down and just move it? And to get there, we basically had a structure that is concerned with the exploratory phase of how we go through this. I wouldn't go into the different points, but we had an organizational pane. What do we do with the gallery? We looked at the actors' experience in the area, and through identifying their groups, goals, paths, and finally draft ecosystem, we were able to create a different sort of synergy between what was the expectations of the gallery itself, or the committee behind the gallery, and what actually people were experiencing. We went through some of the more, elaborated system maps that you all know. This is again a simplified version of the touch points that we identified at different levels, connecting the JAG to students, to the physical location that you can see were sort of isolated on the side, to their bookshop, to the cafeteria, to the different areas. It's very interesting for us that physical location in connection to the Joubert Park, which is the place where it's located, and the way it's signaled all over in terms of signage and stuff were the most isolated parts, the ones that do not belong to the ecosystem. And then, just to show you what we normally do, but we have many different ways, because this is a heuristic process. We're still figuring out how to do it. These were the different channels that were identified, and channels are design artifacts, so they could be anything from an enterprise architecture model to things that the actors tell you. And the way some of these were living on many different channels and allowing people to basically connect to have a better experience. As you can see, some of these were really, really isolated and living on their own path. As for conclusions, the one thing that I can tell you is that this is a sort of like left side design framework for understanding how we go through convergent cross-channel experiences, physical and digital. It allows us to take care of the problem of convergence in products and services, because it has a generative framework, and it allows us to convey the idea of anonymous, multiple mass creation of content that we see on social media in something that designers can manage. There's a lot to do, and this is just the beginning. We've been working on this, so any questions would be very much appreciated. Thank you.
Are there questions?
Small question? Yes. To which extent you are analyzing each channel within your ecosystem?
So channels are not normally analyzed in the way we identify them. We identify the touch points, which are medium specific, so they would live in what McLuhan would call channels in a way. But we don't, because we basically consider the idea of this computer and my badge as two of the touch points for the conference. So this one would live in a physical layer, while that one is probably both in the physical and software layer. The channels are built by the design team based on all of the ethnographic research and actor research that we do at the beginning, and they are used to try and figure out how connected these various elements are. So it might be that they are part of a communication channel. That would be my first stab at it. But it might be also that that channel communication is not so useful in terms of design outcomes. So there's a lot going on, a lot of refinements. Normally this phases takes 1 month to 2 months in the project we've been doing so far. Of course it's overlapping with others, but and normally we've been having 3 to 5 iterations of channels, trying to get to the right ones. So a lot of thought goes into those, but it's sort of like a designerly approach to the problem. So we actually look at what we have and we try to figure out what is going to be useful at the end. So I hope it answers your question.
One question? Yeah. Actually, you introduced a couple of principles or fundamentation for your cross-channel ecosystem, such as actor-driven choices and systematic, and so on. So how this can be mapped from the computer science perspective? It's hard to build any advanced, for example, actor-driven processes because you don't know how they will act, so you cannot enumerate all possible paths. So how can these actors driven by their choice can be supported by ICT or processors or any kind of application?
It's a very, very correct question. It's also a very, very difficult question to answer. I can tell you what we've been playing with so far, not just our group, but also people in Nottingham are working on trajectories with Professor Benford over there. And they have a similar view to ours, but more top-down, while we tend to be bottom-up. The way we are seeing this is that you wouldn't want to model all of the different paths. That's why we go into the ecosystem. We're trying to gather as much information on the touch points that these people basically move through and the whys as to they move through those touch points in order to be able to model the ecosystem and not the individual choices. Because the individual choices are possibly unlimited. I mean, somebody could always, double back 3 times just because there's no way that you can say that. But what we're trying to figure out is a way to model the ecosystem itself so that we can provide, let's make an ecological sort of like parallel. If this was the Serengeti, we are not looking at how many zebras we have or how many lions, but more at how we can provide water holes in order to try and change behavior over time. And in order to do that, we need to have an idea how the Serengeti itself is laid out. Where are the current water holes and what are the plants and where are the groups of animals, but not the individual animals. So we are not really going for the single user, but more for what a number of them go. I didn't say that, but most of the research we've been done so far in terms of the way you normally do things like customer journeys or journey maps in design, we tend to, decuplicate the numbers of those. So we have normally between 50 to 100 users or actors interviewed or poked in some way, observed, in order to get to the point where we have an approximation of what the ecosystem could be, and then we start from there. But of course, it's open. It might be interesting to discuss that.
I have a question about multi-layer and how you put together some effects.
It's sort of like, so far, this has been, as I said, this has been a designer activity. This has been mostly like something done by hand by the design team, by basically merging the different paths. We have a number of tools, and they go from small little software programs that we have by ourselves to actually people doing things using anything from InDesign to Inkscape to the sort of things. But it's a process of multi-layering and overlapping of the different paths to get to the point where we can use some sort of space syntax to understand what nodes are most integrated and how we can change behavior through those.
Thank you once more.
Thank you. Thank you.
Thank you, Anna. You can leave your belongings here. And now we will move to the lunch. Okay? So just keep your belongings here. We're gonna close the door. We're gonna close the building. Don't worry.